Welcome back to the Monotone Museum. Tonight, we add a new exhibit, an exhaustive technical study of the vending machine. Before we examine the 24-volt DC motors and the infrared drop sensors that govern this quiet sentinel, I want to invite you to subscribe and join our archive. We are currently documenting the rhythmic history of the modern world. From the escalators we've already preserved to the spiral talk we'll explore tonight. By subscribing, you ensure these mechanical histories remain accessible to all, who find peace in the engineering of the ordinary. Now settle into your seat. The office lights have dimmed and the break room is empty. Let us begin with the stillness of the refrigeration cycle. In a quiet office building, as the last worker dims the lights and heads home, a vending machine stands alone in the break room. It hums softly, a gentle, almost imperceptible sound. The sound of refrigeration coils doing their patient work. This machine has been here for 7 years, and it will likely be here for 7 more. There is no hurry in the world of vending machines. Only waiting. Only readiness. Let's move closer to this machine, so close we can hear its quiet breathing. The compressor cycles on, a soft whir that lasts exactly 4 minutes and 20 seconds, then falls silent for 11 minutes. This rhythm has repeated 340,000 times since the machine was installed. Each cycle moves refrigerant through copper coils, keeping the sodas at precisely 38 degrees Fahrenheit. Not too cold, not too warm, just right for that perfect first sip. Inside, the machine, 27 different products wait in perfect rows. Each has its place. The machine knows where everything is through a series of simple metal spirals, helixes, really, that hold each item in a gentle embrace. When you make a selection, a small motor awakens. It's been resting, conserving energy, waiting for this moment. The motor turns its assigned spiral exactly 1 3/4 rotations, no more, no less. The can or bottle or snack slides forward, teeters on the edge for just a moment, then tumbles down into the retrieval bin with a soft thud. That sound, the gentle fall of your selection, is the sound of a promise kept. The first vending machine, in its most primitive form, dates back to ancient Alexandria, Egypt, around 215 BCE. A mathematician and engineer named Hero of Alexandria created a device that dispensed holy water in temples. When you placed a coin in the slot, it would land on a small pan attached to a lever. The weight of the coin would tip the lever, opening a valve that released a measured amount of holy water. When the coin slipped off the pan, the valve would close. Imagine that. Over 2,000 years ago, someone understood that machines could serve us while we sleep, while we work, while we live our busy lives. The concept is ancient, patient, timeless. But let's return to our modern machine, standing in its quiet vigil. The lights inside the machine glow softly. LED now, though for decades they were fluorescent tubes that buzzed with a sound like distant bees. The LEDs are better. They're silent. They sip power like a hummingbird sips nectar. They'll last 50,000 hours before they need replacing. That's 5.5 years of continuous illumination. The machine appreciates this efficiency if a machine can appreciate anything. Tonight, the machine is stocked with 12 rows of beverages and 15 rows of snacks. The beverages rest in the back, in the refrigerated section. The snacks sit at room temperature in the front. This layout has been refined over decades. Cold things in back where the cooling coils are. Shelf-stable items in front where it's easier to see them, easier to choose. The machine's control board, its brain in a sense, is a circuit board no larger than a paperback book. On this board, microchips and capacitors and resistors work together to manage every transaction. When you insert money, sensors detect whether it's a dollar bill or a 5, whether the quarters are real or slugs, whether the credit card you've tapped is valid. The machine has learned to be cautious. It's been fooled before. In the 1980s, people would sometimes use photocopy money or foreign coins that were the same size as quarters, but worth less. The machine's designers responded with better sensors, optical sensors that could see the printing patterns on bills, electromagnetic sensors that could detect the specific metal composition of legitimate coins. The machines learned. They evolved. Our machine accepts bills now, sliding them in with a gentle, motorized pull. The bill travels past several sensors. One checks the magnetic ink, another examines the paper's reflectivity, a third measures its thickness. All of this happens in less than 2 seconds. If everything checks out, the bill continues to a stacker box where it joins other bills, all facing the same direction, all stacked neatly like a deck of cards. The machine is organized. It has to be. Every week, a person comes to service the A machine. They have a key, one of only 3 copies in existence. They open the front panel, revealing the machine's inner workings. They collect the money from the stacker box and the coin mechanism. They restock the spirals, they check the temperature, they wipe down the glass. Then they lock it up again and move on to the next machine on their route. They service 42 machines in a single day, 5 days a week. They know each machine's quirks. This one's compressor is getting a little loud. That one's bill acceptor sometimes jams on very new, very crisp bills. But mostly, the machines just work. They work in the way that reliable things work, quietly, without complaint, without need for praise. Let's think about the spiral mechanism, because it's quite beautiful in its simplicity. Picture a spiral made of thick wire, like a spring that's been stretched out. Products nestle in the spaces between the coils. When the motor turns the spiral, the product is pushed forward by the coil behind it. Gravity does the rest. No complicated robotics, no pneumatics or hydraulics, just a turning spiral and gravity working together as they have since the first modern vending machines appeared in the 1880s. Those early machines sold postcards and chewing gum. A penny would buy you either one. The mechanisms were entirely mechanical. Springs and levers and weights, all carefully balanced. If you didn't put in enough money, the machine simply wouldn't move. If you put in too much, well, that was your mistake. The machine kept the excess. Early vending machines were honest but not generous. As you rest now, imagine the millions of vending machines standing in their places around the world. In Tokyo, there are vending machines that sell hot coffee in cans, keeping them warm at 140 degrees Fahrenheit, ready to heat your hands on a cold morning. In Rome, there are machines that dispense fresh pizza, cooking it in 3 minutes while you wait. In Dutch train stations, machines sell fresh flowers. In Singapore, machines dispense entire meals kept fresh in refrigerated compartments. But most machines like ours are simpler. They offer familiar things. Chips, candy bars, soft drinks, a bit of sustenance, a small comfort, available any time of day or night. The machine doesn't sleep. When the office is empty and dark, when everyone has gone home to their dinners and their televisions and their beds, the machine continues its work. The compressor cycles. The lights glow. The control board maintains its vigil, ready to accept money, ready to vend. There's something peaceful about this, isn't there? The idea that somewhere, something is always ready to serve, always patient, always there. Let's explore deeper now, into the mechanisms themselves. Let your mind drift with me into the inner workings, where metal and electricity perform their quiet ballet. The coin mechanism is a marvel of precision. When you drop a quarter into the slot, it enters what's called a coin runway, an angled pathway that lets the coin roll on its edge. As it rolls, it passes through a series of gates and sensors. The first sensor is optical. A beam of light shines across the runway, and the coin's shadow tells the machine its diameter. Is it quarter-sized, nickel-sized, dime-sized? Next, the coin passes through an electromagnetic field. Different metals interact with electromagnetic fields in different ways. Copper, zinc, nickel, each has a unique electromagnetic signature. The sensor can tell if your coin is made of the right metals in the right proportions. A genuine quarter is made of a copper core sandwiched between 2 layers of cupro-nickel alloy. 75% copper and 25% nickel. The sensor knows this. It's been calibrated to recognize it. If the coin passes these tests, a small gate swings open and the coin falls into the acceptance channel, landing in a coin box with a satisfying clink. If it fails, a different gate opens, and the coin slides down the return chute, back to you. The machine is sorry, but rules are rules. This entire process takes less than 1 second. The coin rolls, the sensors analyze, the gates respond. It happens so quickly you barely notice, but it's happening every time with mechanical precision. The bill acceptor is even more sophisticated. Modern bill acceptors use a combination of sensors that would seem like science fiction to someone, from even 30 years ago. When you slide a dollar bill into the slot, rubber rollers grab it and pull it deeper into the machine at a speed of exactly 3.2 inches per second. This controlled speed is important. It gives the sensors time to do their work. The bill passes under an infrared scanner that reads the pattern of the printing. Each denomination of currency has a unique infrared signature because the inks are slightly different. A $1 bill looks different under infrared than a $5 bill, which looks different from a 20. The scanner compares what it sees to patterns stored in its memory. Does this match? Is this authentic? Next, the bill passes under an ultraviolet light. Real currency has fibers embedded in the paper that fluoresce under UV light. Counterfeit bills usually don't have these fibers, or they have the wrong kind. The machine checks. It's thorough. Magnetic sensors sweep across the bill, reading the magnetic ink used in the printing. The amount and pattern of magnetic ink is consistent on real bills, inconsistent on fakes. Another test passed. Finally, sensors measure the bill's thickness. Real currency is printed on a paper made from cotton and linen, not wood pulp. It has a distinctive thickness and texture. The sensors can feel this in their way. All of this analysis happens as the bill travels about 8 inches through the acceptor. If everything checks out, the bill continues to the stacker box. If anything seems off, the rollers reverse, and the bill is politely returned to you. Try again, perhaps with a different bill. The machine will wait. Inside the stacker box, bills accumulate throughout the day. The mechanism keeps them organized, all facing the same direction, tamped down neatly. A typical stacker box can hold about 500 $1 bills, though it works just as well with 5s, 10s, or 20s. The machine doesn't care about the denomination, not really. It just counts the value and keeps track. When you've inserted enough money for your selection, a green light illuminates on the keypad. Now you may choose. The keypad itself is a simple membrane switch array. Press a button, and you're completing an electrical circuit. The control board detects which circuit has been completed and knows which selection you've made. A3? That's row A, position 3. The machine sends power to the motor for spiral A3. The motor is a small DC motor, the kind that might power a toy car, but geared down for torque rather than speed. It turns slowly, deliberately, pushing your selection forward until gravity takes over. Some modern machines have replaced the spiral system with a different mechanism, the drop box system. In these machines, products sit in individual boxes with trapdoors on the bottom. Select a product, and an electric solenoid pulls a latch, releasing the trapdoor. The product falls directly down to the retrieval bin. This system works well for fragile items, bags of chips that might get crushed in a spiral, or candy bars that might get stuck. But most machines still use spirals because they're simpler, more reliable, and easier to service. Our machine uses spirals, and it's been doing so without complaint for 7 years. In that time, its spirals have rotated over 45,000 times. The motors have been very patient, very reliable. Only once did a motor fail, and it was replaced within a day by the service technician who knows this machine like an old friend. Let's drift now to the refrigeration system, because it's working even as we speak, even as you rest, keeping everything at that perfect temperature. The refrigeration system in a vending machine is essentially a small air conditioner running in reverse. At the heart of it is a compressor, a pump that compresses refrigerant gas. When gas is compressed, it heats up. The hot compressed gas flows through a series of coils on the back of the machine. These are the condenser coils, and as the hot gas flows through them, it releases heat into the room. You might have felt this if you've ever stood behind a vending machine. That warm air is the heat being pulled from inside the machine and released outside. As the gas releases heat, it condenses into a liquid. This liquid refrigerant then flows through an expansion valve, which is like a tiny nozzle. As the liquid is forced through this restriction, it expands rapidly and evaporates, turning back into a gas. When liquids evaporate, they absorb heat from their surroundings. This is why sweating cools you down. The evaporating sweat absorbs heat from your skin. Inside the vending machine, the evaporating refrigerant absorbs heat from the air around the beverages. This cooled air is circulated by a small fan. The now warm refrigerant gas flows back to the compressor, and the cycle begins again, over and over, dozens of times an hour, for years on end. The thermostat monitors the temperature inside the cold section. If it rises above 40 degrees Fahrenheit, the compressor kicks on. If it drops below 36 degrees, the compressor shuts off. This 4-degree range is the machine's comfort zone. It keeps the sodas cold, but not frozen, perfect for drinking. In a year, the compressor will run for approximately 4,000 hours, about 45% of the time. The rest of the time, it rests, letting the insulation do its work. The machine is insulated with foam, usually polyurethane, which slows the transfer of heat from the warm room to the cold interior. Good insulation means less work for the compressor, less electricity consumed, lower operating costs. The machine is efficient because efficiency is elegant, and elegance is worth pursuing even in a vending machine. Now let's think about the machine's awareness, its ability to know what it contains. Newer machines like ours have sensors that detect when a product has been dispensed. An infrared beam shines across the retrieval bin. When your product falls and breaks this beam, the machine knows the vend was successful. It can log this information, keeping track of what's been sold. This data helps the service technician know what to restock. If the machine sells through all its cola in 2 days, but the lemon lime soda lasts 2 weeks, the technician will adjust the next stock order accordingly. The machine is teaching its human partner about the preferences of its customers. Some very advanced machines can even detect when a product gets stuck. When the spiral turns, but the infrared beam is never broken, these machines can attempt a second vend automatically, turning the spiral again to try to dislodge the stuck item. If that doesn't work, they can display a message. Please contact the service number for a refund. The machine is apologetic. When it fails, it wants to make things right. But most vends succeed. The spiral turns, the product falls, the retrieval door is opened, and a hand reaches in to claim what's been purchased. The transaction is complete. The machine returns to waiting. Let's drift back in time now, gently, peacefully, to understand how we arrived at these quiet mechanical servants. The first automatic vending machines in America appeared in the 1880s on the platforms of elevated railways in New York City. They sold chewing gum, tutti frutti gum, manufactured by the Adams Gum Company. For a penny, you could get a stick of gum without interacting with a shopkeeper. This was revolutionary. The machines worked day and night. They didn't take lunch. Breaks. They didn't need sleep. The Thomas Adams Gum Company realized something important. These machines could go places where it wasn't economical to have a human vendor. Subway platforms, train stations. Anywhere people gathered briefly and might want a small convenience, the machines spread quickly. By 1897, there were vending machines selling postcards, cigars, and even hot meals on train platforms across the country. Picture those early machines, tall, ornate, often made of cast iron with decorative flourishes. They were designed to be beautiful as well as functional. Some had painted scenes or embossed patterns. They were furniture, in a way, meant to occupy public spaces with dignity. The mechanism inside was purely mechanical. Drop a coin in the slot, and its weight would trigger a lever that would release the product. Simple, reliable, no electricity needed. As you rest now, imagine the sound of those old machines, the clink of a penny dropping, the clack of a lever releasing, the soft thud of gum, or a postcard landing in the retrieval area, sounds that echo down through more than a century. The first refrigerated vending machine was introduced in the 1930s. The Vendolator company created a machine that could keep bottles of Coca-Cola cold. Before this, vending machines had sold products at room temperature. The refrigerated machine changed everything. Now you could get a cold drink automatically anytime. The machine used the same refrigeration technology that was being installed in homes, a compressor, refrigerant, coils, but scaled down, made efficient, designed to run continuously. These early refrigerated machines were expensive to operate. Electricity wasn't cheap, and the refrigeration systems weren't as efficient as modern ones. But they offered something valuable: the promise of a cold drink on a hot day, available instantly, with no human interaction required. People were willing to pay for this convenience. During World War II, vending machines took on new importance. With so many workers in factories supporting the war effort, often working long shifts at odd hours, vending machines provided sustenance when cafeterias were closed. Candy bars, sodas, cigarettes. These machines kept workers fed and alert. The technology improved rapidly during these years. Manufacturers learned to make machines more reliable, easier to service, more resistant to tampering. After the war, vending machines spread everywhere. By the 1950s, you could find them in every office building, every factory, every school. They sold coffee, soup, sandwiches, ice cream. In Japan, entrepreneurs went even further, creating machines that sold fresh eggs, rice, and vegetables. The machines were becoming more sophisticated, with better refrigeration, better heating elements for hot drinks, better coin mechanisms. The 1970s brought computer chips to vending machines. Suddenly, machines could track inventory electronically. They could accept paper money. They could display digital messages. A vending machine could tell you if it was out of your selection before you put in your money. It could give change. It could even refuse service if it detected tampering or if it had malfunctioned. In the 1990s, machines began accepting credit cards and debit cards. A small card reader would be installed, and with a swipe, you could make a purchase. No need for exact change, no need to carry cash at all. The machines were adapting to how people wanted to interact with them. Now, in our current age, machines accept contactless payments. Tap your phone or your card, and the payment processes in less than a second. Some machines have touchscreens, where you can see pictures of every product, read nutritional information, even watch a short video about what you're buying. The machines have cameras that can do facial recognition. Though this feature is controversial, and many people prefer machines that respect their privacy by simply offering products without watching them. But through all these changes, the fundamental promise remains the same. Put in money, select a product, receive that product. The machines are still doing what they've always done. They're just doing it with more sophistication, more awareness, more attention to the customer's needs. Let yourself imagine, as you drift towards sleep, the first person who used a vending machine in 1888, dropping a penny in for a stick of gum. Connect that moment, to the machines that stand in hallways and break rooms today. The thread runs unbroken through 135 years. Humans creating machines to serve other humans. Machines patiently waiting to do exactly that. Now let's take a journey around the world, visiting the vending machines of different cultures, different needs, different dreams. In Japan, vending machines are ubiquitous. There's approximately one vending machine for every 23 people in the country. That's over 5 million machines standing in the streets, in the subway stations, outside shops, in residential neighborhoods. The Japanese have embraced vending machines in a way no other culture has. Perhaps it's because Japan values efficiency, automation, and the ability to conduct transactions without lengthy social interactions. The machines provide service without burdening anyone. Japanese vending machines sell everything you can imagine. Cold coffee in summer, hot coffee in winter. The same machine, with heating elements and cooling elements, adjusting its offerings with the seasons. There are machines that sell umbrellas when it starts to rain, activated by moisture sensors. Machines that sell fresh eggs, dispensing them gently so they don't crack. Machines that sell neckties for businessmen who've forgotten theirs at home. Machines that sell hot soup in cans, perfect for a cold evening. Machines that sell fresh rice, milled to order. The variety is endless. Some Japanese machines are highly specialized. At some airports, there are machines that sell kits for making onigiri, rice balls. The kit includes the rice, the seaweed wrapper, and a filling. In Hokkaido, where winters are harsh, there are machines that sell fresh-baked potatoes kept warm at 180 degrees Fahrenheit. In Buddhist temples, there are machines that sell omikuji, fortune-telling papers, as a modern interpretation of an ancient tradition. The machines in Japan are also extremely reliable and well-maintained. Vandalism is rare. The machines are treated with respect, as if they're members of the community. In some neighborhoods, elderly residents rely on the machines, and the service technicians who restock them serve an unofficial role as wellness checkers, making sure regular customers are still making their usual purchases. Travel west now, across the ocean, to Europe. In Italy, there are machines called Casa di Pizza that make fresh pizza while you wait. You select your toppings on a touch screen, and inside the machine, a robotic arm spreads sauce and cheese on fresh dough, adds your chosen toppings, and then slides the pizza into an infrared oven. In 3 minutes, the pizza is baked and delivered to you through a door, hot and ready to eat. The machines are surprisingly popular, operating 24 hours a day in major cities. In France, there are machines that dispense fresh baguettes. The bread is baked earlier in the day and kept in climate-controlled compartments to stay fresh. While French citizens still prefer buying bread from a boulangerie, these machines serve as a backup for when the shops are closed. Sunday evenings, late at night, early in the morning, the machines preserve the tradition of fresh bread while adapting to modern schedules. In Germany, vending machines are extremely popular at train stations, dispensing everything from sausages to technology accessories. German machines are known for their robust construction and precise engineering. The mechanisms are built to last decades, not just years. Service intervals are planned precisely. Everything is documented, tracked, optimized. Travel south to Singapore, where the heat and humidity pose special challenges for vending machines. Here, machines must work harder to keep drinks cold. The refrigeration systems run longer, fight against higher temperatures. Singaporean machines often have additional features like dehumidifiers to prevent condensation from damaging electronic components. The machines adapt to their environment just as living things do. In Australia, remote mining towns rely heavily on vending machines because there aren't enough people to support a staffed shop. A single vending machine can serve a town of 50 people, restocked once a week by truck. These machines carry not just snacks and drinks, but necessities, batteries, first aid supplies, phone chargers. In the Australian outback, a vending machine might be the only retail option for 100 kilometers. In the United States, vending machines reflect regional preferences. In the South, you're more likely to find sweet tea and moon pies. In the Northeast, egg creams and black and white cookies. In the Southwest, machines might stock Doritos and Mexican candies. In the Pacific Northwest, locally roasted coffee and craft sodas. The machines know their audience. They stock what sells. American schools have their own vending machine culture. For years, machines stocked with sugary sodas and candy were common in hallways. But as awareness of childhood obesity grew, many schools changed their policies. Now, school vending machines more commonly offer water, juice, granola bars, and fruit. The machines adapted because the needs of their community changed. In hospitals, the vending machines serve families keeping vigil through long nights. These machines are stocked with care: coffee for staying awake, crackers for unsettled stomachs, juice for children, bottled water for everyone. Hospital vending machines are serviced more frequently than most because the need is greater. Running out of stock in a hospital waiting room is a small crisis. The service technicians know this. They're attentive. Prisons also use vending machines, but with special security features. The machines are built extra sturdy, bolted to floors and walls. The payment systems often use special tokens or cards instead of cash. The selection is carefully curated. Nothing that could be turned into a weapon, nothing with alcohol, nothing that could be used to make illicit substances. Within these constraints, the machines still try to offer comfort: snacks, sodas, coffee. Small pleasures in a constrained environment. Let your mind wander now through all these machines, all these places. In every time zone, At this very moment, millions of vending machines are standing ready. In Tokyo, a salaryman is buying hot corn soup at 2 a.m. In Paris, someone is purchasing a fresh baguette before sunrise. In Sydney, a nurse on a night shift is getting a chocolate bar for an energy boost. In New York, a security guard is buying Ace coffee to stay alert. The machines serve them all, patiently, without judgment, without complaint. Let's dive deeper now into something beautiful: the geometry and mathematics that make these machines work. As you drift, let these numbers and shapes create patterns in your mind, soothing patterns, like counting sheep, but more elegant. The spiral mechanism is based on the Archimedean spiral, named after the Greek mathematician Archimedes, who studied it in the 3rd century BCE. An Archimedean spiral is a curve where the distance between successive turns remains constant. If you look at a vending machine spiral from the side, you'll see this. Each loop of the spiral is exactly the same distance from the previous loop. For a standard soda can, that distance is 2.6 inches, the width of the can. The spiral itself is made from steel wire, usually about 3 to 8 inch in diameter. It's strong enough to push a full can forward, but flexible enough to be wound into a spiral shape. The wire is coiled around a central rod, the spiral's axis. A typical spiral makes 8.5 complete revolutions from back to front. That means it can hold up to 8 products, 1 in each space between revolutions, with a half space at the end. The motor that turns the spiral rotates at 60 revolutions per minute when it's running. But it doesn't run continuously. It only turns for about 3 seconds per vend. In that time, it rotates 1.75 times, which is exactly enough to advance in one product to the edge where gravity takes over. The gearing is precise, too little rotation, and the product doesn't reach the edge. Too much, and you'd dispense 2 products instead of 1. The torque required to turn a spiral loaded with 8 soda cans is approximately 45 Newton meters. The motor needs to be strong enough to overcome the friction of the cans sliding forward, and the resistance of the spiral flexing slightly under load. Engineers have calculated these forces precisely, choosing motors that can reliably deliver this torque tens of thousands of times over the machine's lifetime. The angle of the spiral's pitch, the angle at which the wire rises as it winds around, the central rod is typically 12 degrees. This angle is a compromise. A steeper angle would hold products more securely, but would require more torque to turn. A shallower angle would be easier to turn, but might let products slip backward when the machine is jostled. 12 degrees has been found, through decades of trial and error, to be just right. When a product reaches the edge and falls, it travels approximately 18 inches before landing in the retrieval bin. Physics tells us that an object in free fall will drop 18 inches in about 0.34 seconds. The impact velocity when it hits the bottom is roughly 11 feet per second. This is fast enough that you hear a satisfying thud, but not so fast that fragile products break. Engineers have studied these impact forces, designing the retrieval bin floor with just enough give to cushion the landing. Often, the floor is made of rubber or plastic rather than metal, absorbing some of the shock. The spacing between spirals is also mathematically determined. Each spiral is mounted 3.25 inches from the next. This spacing accommodates the width of a standard soda can, 2.6 inches, plus a small gap for the mounting hardware and to prevent spirals from interfering with each other. A typical machine has 10 to 12 spirals across its width, which means the in-total width of the cold section is about 36 inches. Exactly 1 yard, a pleasingly round number. The keypad that lets you select your product follows a standard numbering system. Letters across the top, A, B, C, D, and so on. Numbers down the side, 1, 2, 3, 4, and so on. Press A3, and you're selecting the spiral in column A, row 3. This grid system can accommodate up to 80 different selections in a large machine, wide each aced, columns x 10 rows. Though most machines have fewer options, the electrical current that powers the motors is carefully regulated. Each motor draws about 1.5 amperes when running. The machine's power supply can provide up to 20 amperes total, enough to run all the motors at once if needed. though this never happens. Selections are processed sequentially, one at a time. The voltage is typically 24 volts DC for the motors, stepped down from the 120 volts AC provided by the wall outlet. This lower voltage is safer and more suitable for the precision control needed. The machine's total power consumption varies with use. When idle, with just the lights and control board active, it draws about 50 watts, roughly the same as a laptop computer. When the refrigeration system is running, consumption jumps to 450 watts. During peak cooling times on a hot day, the machine, it might run the compressor 70% of the time, averaging 350 watts continuously. Over a month, this works out to about 250 kilowatt hours, or roughly $35 worth of electricity at average rates. This is the machine's operating cost, the price of its constant readiness to serve. Let these numbers wash over you now. The precision. The care taken in every measurement, every calculation. Nothing is arbitrary. Every dimension, every angle, every timing interval has been considered, tested, refined. The machines are the product of thousands of engineers over more than a century, each one adding a small improvement, solving a small problem, making the mechanism a little more reliable, a little more efficient. Return with me now to our machine. In the office break room, the building is dark. It's 3 a.m. Everyone is home, asleep in their beds, just as you're drifting now towards sleep. But the machine is awake in its way. Its consciousness is minimal, just sensors and circuits, but it's attending to its duties. The compressor clicks on, the evaporator fan begins to spin, cool air circulates around the beverages. The machine is maintaining its promise. When someone arrives in the morning, the drinks will be cold, perfectly cold, exactly as they should be. In the snack section, bags of chips rest against each other. Doritos, Cheetos, pretzels. They're not refrigerated, they don't need to be, but they're organized, ready. Behind them, the spirals wait to turn. If machines could think, what would this machine think about during these long, quiet hours? Perhaps it would think about the people it serves. The young programmer who always buys the same thing, Coke Zero and peanut M&Ms, at 2:30 every afternoon. The machine knows this person by the timing of the selection, by the pattern, the administrative assistant who gets green tea and almonds, the CEO who buys sparkling water, the janitor who comes by at 6 a.m. before anyone else arrives and gets a Snickers bar and a coffee. The machine knows these patterns, even though it has no way to know the people themselves. It just records A3 selected at 14:31, D2 selected at 14:33. Over days and weeks, patterns emerge. The machine doesn't judge, it just serves. Sometimes someone makes a selection and nothing happens. The spiral turns, but the product is wedged at an angle. It doesn't fall. The person might shake the baby mum. Machine, frustrated? The machine feels this. Accelerometers detect the motion, but it can't respond. It has done what it was asked to do. The spiral turned. The fault lies in how the previous customer placed the product when restocking, or in a slight misalignment that has developed over time. The machine wishes it could help, in whatever way a machine wishes anything. But it can only wait for the service technician to come and fix things. Most of the time, though, things work. The spirals turn, products fall, people are satisfied. This is the machine's purpose, and it fulfills this purpose thousands of times before it needs attention. Let's sit with the machine in its silence. The hum of the compressor, the soft whir of the fan, the occasional click of the thermostat. These are the sounds of dedication, of service, of patience. In a world that demands so much of us, that rushes and stresses and never seems to rest, there's something deeply calming about a machine that simply does its job, hour after hour, asking nothing in return except electricity and occasional maintenance. The machine is not ambitious. It doesn't want to be more than it is. It's not trying to become sentient or take over the world. It just wants to give you a cold Sprite when you need one. This simplicity of purpose is beautiful. In Zen Buddhism, there's a concept called suchness, the idea that everything has its own nature, its own way of being, and this is complete and perfect as it is. A rock is perfectly a rock. A tree is perfectly a tree. And a vending machine is perfectly a vending machine. It serves. That is its nature. That is its suchness. As you rest now, consider this suchness. The machine in the break room, the machine in the hospital, the machine on the train platform in Tokyo. They are all being exactly what they are, completely and without pretense. There's a peace in this, a rightness. Every machine exists in an ecosystem. Let's explore the web of relationships that surround our vending machine. First, there's the service technician. Let's call him Marcus. Marcus has been servicing machines for 12 years. He knows hundreds of them across the city. He visits our machine every Tuesday at 11 a.m. He brings new stock in a truck, cases of soda, boxes of chips, candy bars in bulk. He has a key. He opens the machine and counts what's sold. He removes the money and records it in his tablet. He loads new products into the spirals, working from back to front, filling each space. Marcus knows this machine's history. He replaced the compressor 3 years ago when the old one finally gave out after a decade of service. He's adjusted the coin mechanism twice when it started rejecting too many valid quarters. He's replaced the LED light strips once. He knows that this machine sells more diet drinks than regular ones, which is unusual. He stocks accordingly. Marcus has a relationship with this machine. Not a personal relationship. He doesn't name it or talk to it, but a professional one. He knows its quirks. He respects its reliability. When it does fail, he fixes it quickly because he knows the people in this office rely on it. It's part of his route, part of his responsibility. Then there's the building maintenance staff. They make sure the machine's electrical outlet is working, that the breaker doesn't trip. Once, a cleaning crew accidentally unplugged the machine while vacuuming. The next morning, all the sodas were warm. The maintenance supervisor apologized to Marcus when he came for his regular visit. They plugged it back in, and within 4 hours, everything was cold again. The machine recovered. It was resilient. There's the property owner who approved the machine's installation 7 years ago. They get a small commission on every sale, 5% of revenue. It's not much, perhaps $200 per month, but it adds up. More importantly, the machine makes the building more attractive to tenants. Small amenities matter. There are the suppliers, the Coca-Cola distributor, the Frito-Lay route driver, the candy wholesaler. They supply the products that Marcus stocks. They deliver to a central warehouse where Marcus picks up his weekly stock. These suppliers are also in relationship with the machine, indirectly. If the machine is well maintained and fully stocked, their products sell. If it's broken or empty, sales suffer. There are the manufacturers who built the machine in the first place. This machine was built by Crane Merchandising Systems at a factory in South Carolina. Assembly line workers bolted it together, tested it, packed it for shipping. Engineers designed every component. Purchasing agents sourced the parts. Quality control inspectors checked the thermostat, the coin mechanism, the motors. All of these people, though they've never visited this office break room, are connected to this machine. There are the people who mine the metals and pump the oil that became the plastics and manufacture the electronic components. There are the truck drivers who transported the machine across the country. There are the electricians who installed the outlet it plugs into. There are the utility workers who maintain the power grid that keeps it running. When you press a button and a soda drops, you're the endpoint of this vast network of human effort. Thousands of people have contributed to this moment. The machine is a node in a web that spans the globe. And then there are the indirect relationships. The machine affects the office culture. It's a gathering place, a conversation starter. Want to take a walk to the vending machine? Is a way to suggest a break, a chance to chat. The machine enables small social rituals. The machine, in its passive way, brings people together. Some environmentalists criticize vending machines for their energy use and for encouraging consumption of packaged goods. This criticism is valid. The machine does use electricity continuously. The products it sells do come in single-use containers. But the machine doesn't make these choices, humans do. The machine just serves what it's asked to serve. If stocked with healthier options in recyclable containers, it would serve those just as faithfully. Some machines now have solar panels on top, generating some of their own power. Some have motion sensors that dim the lights when no one is nearby. The machines are evolving to be more sustainable, because the humans who design them are making different choices. The machines adapt, they serve. What does it mean to wait? The machine waits constantly. It waits for a customer. It waits for maintenance. It waits for the compressor to cycle. It waits for the service tech to restock. Waiting is its primary state of being. But the machine's waiting is not empty. It's a ready waiting, an active waiting. At any moment, the machine is prepared to act. Someone inserts money, and instantly, within milliseconds, the machine responds. It doesn't need to wake up or prepare. It's already ready. It's been ready. All along. This is different from how we wait. When we wait for a bus, we're idle. We're suspended between states, not quite here and not quite there. We check our phones. We look down the street impatiently. We wish the waiting would end. The machine doesn't wish. It doesn't experience impatience. It simply maintains readiness. If no one uses it for a week, it's the same as if someone uses it every 5 minutes. The machine doesn't prefer one state over the other. It accepts what comes. There's a Buddhist parable about a monk who was asked, "What do you do all day?" The monk replied, "I chop wood and carry water." The questioner pressed, "But what's special about that?" "Anyone can chop wood and carry water," the monk answered. "When I chop wood, I chop wood. When I carry water, I carry water." The vending machine is like this monk. When it cools beverages, it cools beverages. When it vends a product, it vends a product. It's fully present in each action, not wishing to be doing something else, not planning ahead, not regretting the past, just doing what it does. In our human lives, we often struggle with waiting. We want things to happen faster, we're impatient with delays. We feel that waiting is wasted time. But what if we could wait like the machine waits? Ready, but not anxious. Prepared, but not impatient, simply present. The machine teaches patience through its example. It will give you your snack when you're ready, not before. It won't rush you. You can stand in front of it for 5 minutes, deciding what you want, and it will wait. It won't tap its foot or sigh or check its watch. It has infinite patience because it exists in a different relationship with time. For the machine, time is just a measurement of cycles. The compressor has run for 4,000 hours this year. The spirals have turned 45,327 times in 7 years. These are just numbers, recording what has happened. The machine doesn't experience time as dragging or flying. It just marks the cycles. What would it be like to experience time this way? To not feel it pressing on you, rushing you, running out? To simply notice it passing, marking it like the machine marks its compressor cycles, without judgment or anxiety. This is an invitation. As you drift towards sleep, imagine yourself as the machine. You don't need to rush tomorrow. You don't need to worry about it. You just need to be ready, in the way the machine is ready, calmly, completely, without strain. Even machines break down. It's inevitable. Parts wear out, mechanisms fail. But there's beauty in repair, in renewal, in fixing. What's broken? Let's say the compressor fails. Marcus arrives for his weekly service and finds that the sodas are all warm. He checks the compressor. It's not running. He checks the electrical connections. They're fine. He checks the thermostat. It's calling for cooling, but the compressor isn't responding. The compressor has failed. After 10 years of faithful service, it's simply worn out. Marcus calls his supervisor. They discuss whether to repair the machine or replace it entirely. The machine is 7 years old, not ancient, but not new. However, it's still in good condition otherwise. The decision is made. Replace the compressor, keep the machine in service. 3 days later, Marcus returns with a new compressor. It takes him 4 hours to install it. He has to recover the old refrigerant properly. It's illegal and environmentally harmful to just vent it into the atmosphere. He disconnects the old compressor, removes it from its mounting brackets, installs the new one, connects it to the refrigerant lines. charges the system with fresh refrigerant, tests it. The new compressor hums to life. Within 2 hours, the sodas are cold again. This repair will extend the machine's life by another 7 or 8 years. The new compressor is more efficient than the old one. Technology has improved in the decade since the original was manufactured. The machine will use slightly less electricity now, save a few dollars a year. It's been renewed. There's something hopeful about repair. In our disposable culture, we often throw things away when they break, but repairing is different. It says, this thing has value. This thing is worth saving. This thing can continue to serve. The machine never knows it's been repaired. From its perspective, if we can use that word, nothing changed. One moment the compressor was working, then it wasn't, then it was again. The machine doesn't remember the intervening days when it sat in the break room, unable to cool, unable to serve. Those days are just a gap in its memory, like the gap in your memory between falling asleep and waking up. But Marcus knows. He takes satisfaction in the repair. He's fixed something. He's extended its service life. In a small way, he's fought against entropy, against the natural tendency of things to break down and stop working. He's won that fight, at least for now. Repairs are often invisible to the customer. You use the machine on Monday, it's working fine. You use it on Tuesday, it's out of order. You use it the following Monday, it's working again. You might not even notice that the compressor is new, that Marcus spent 4 hours on Friday making this happen. The machine's service is supposed to be invisible. When it's working correctly, you don't think about it at all. This invisibility is the sign of good design. The machine should just work, fading into the background of your life. It should be there when you need it, and forgotten when you don't. Like plumbing, like electricity, like all the infrastructure we depend on but rarely consider. It's 2:45 a.m. now. In the hospital down the street, someone walks into the waiting room and approaches the vending machine there. They're exhausted. They've been here for 18 hours while their mother had surgery. She's stable now, sleeping. They need something, anything, to keep their energy up for a few more hours. They stare at the machine's selections. Everything looks artificial under the fluorescent lights, but they're too tired to care about nutrition. They select B6, a package of powdered donuts. The spiral turns, the package falls. They retrieve it, tear it open, each standing there in front of the machine. The machine has provided a small comfort in a difficult night. It can't heal anyone. It can't make bad news better. But it can give someone a burst of sugar when they need it. A small familiar pleasure in an unfamiliar, stressful environment. This is the machine's gift. Predictability, reliability, simple fulfillment of basic needs. 3 blocks away, at a 24-hour gym, someone else approaches another vending machine. They've just finished a workout. They buy a protein bar and a sports drink. The machine serves them efficiently, supporting their goals, their effort to be healthier. In a college dormitory across town, a student who's been studying all night buys an energy drink from the vending machine in the basement. They have an exam in 5 hours. They need to stay awake. The machine provides what they need. At a truck stop on the highway, a driver who's been on the road for 8 hours buys coffee from a vending machine. The coffee is mediocre, but it's hot and caffeinated. It will keep them alert for the next leg of their journey. All over the city, all over the world, vending machines are serving people in the middle of the night. They're the only shops open. They're automated commerce. Capitalism's answer to the fact that humans need things at all hours. They're not perfect. The food they offer is often not the healthiest, but they're there. They're reliable. There's something. There's a loneliness to using a vending machine at 3 a.m. You're probably alone in the hallway, or the waiting room, or wherever the machine is. There's no human interaction. No cashier to smile at you or wish you a good night. Just you and the machine, conducting a transaction in silence. But maybe that's okay. Maybe sometimes we don't want human interaction. Maybe sometimes we just want our candy bar or our coffee without having to make small talk, without having to be seen. The machine offers this: anonymous service, neutral service, judgment-free service. It doesn't care why you're buying chocolate at 3 a.m. It just gives you your chocolate. There's freedom in this anonymity. The machine doesn't know you're buying your third soda of the day. It doesn't judge your choices. It just serves. For someone who's feeling judged by the world, this neutrality can be a relief. As you drift now toward deeper sleep, imagine all these machines, all these transactions happening in the night. The lonely student, the worried family member, the tired trucker, the dedicated athlete. All being served by patient machines that wait in the darkness, ready to dispense small comforts to anyone who needs them. Every machine has its own language, though it doesn't speak in words. Let's learn to listen to what our vending machine says through its sounds, its lights, its movements. The hum of the compressor. This is the machine saying, "I'm working, I'm maintaining the cold, everything is normal." The hum is steady, unchanging. If it were to become louder or develop a rattle, that would be the machine saying, "Something is wrong, I need attention." But for now, the hum is peaceful, constant. The soft whir of the evaporator fan, this says, "I'm circulating air, I'm distributing the cold evenly, trust me." The fan runs whenever the compressor runs. If you listen closely, you can hear the pitch change very slightly as the fan blades cut through air of different temperatures. This is the machine's breath, its respiration. When you insert money, listen to the clicks and whirs. The bill acceptor's rollers engage with a soft hum. If the bill is accepted, you hear a gentle mechanical sound as it's pulled into the stacker. The machine is saying, "I've received your payment. Thank you. You may now select." If the bill is rejected, it's pushed back out with a slightly different sound, firmer, more decisive. "This bill is not acceptable. Please try another." The lights on the keypad speak too. Before you've paid, the whole keypad is dark. After payment, specific, buttons light up. Only the ones corresponding to items that are actually in stock and that you've paid enough for. The machine is saying, "These are your choices. Choose from among these." If you press a button that's not lit, nothing happens. The machine is firm, but not rude. It simply doesn't respond to invalid inputs. When you make your selection, you hear the motor engage. It's a grinding sound, not unpleasant, the sound of metal turning, gears meshing, work being done. Then comes the best sound. The soft thud of your product hitting the retrieval bin. Success. Transaction complete. The machine has kept its promise. Sometimes the machine speaks in lights on its control panel. A blinking red light might mean the compressor has failed. A flashing yellow light might mean the bill acceptor is jammed. These are distress signals, calls for help. The machine can't fix itself, but it can announce that it needs fixing. The machine also communicates through its display, if it has one. Insert money, it might say, or make selection, or take item. These messages are simple, direct. The machine doesn't waste words. It tells you exactly what you need to know and nothing more. Some modern machines have error codes. Error 42 might mean the temperature sensor has failed. Error 17 might mean a motor isn't responding. These codes are a language Marcus understands. He has a manual that translates them. Error 42. Check thermostat wiring. He knows what to do. But even without error codes, an experienced technician can diagnose problems by listening to the machine. A compressor that's struggling might hum at a lower pitch. A fan with a worn bearing might develop a slight squeak. A motor that's about to fail might hesitate before engaging. The machine tells its story to those who know how to listen. You too can learn this language. Next time you use a vending machine, pause for a moment. Listen to it. Notice its sounds. Each sound is the machine doing its work, following its programming, fulfilling its purpose. The machine is having a conversation with you in its own way. If machines could dream, what would they dream about? Perhaps our vending machine dreams of perfect service. In this dream, every spiral is perfectly aligned. Every motor responds instantly. The compressor never fails. The temperature is always exactly 38 degrees. Every bill is accepted on the first try. Every product falls cleanly into the retrieval bin. No one ever shakes the machine in frustration. Everyone gets exactly what they wanted, when they wanted it. In this dream, Marcus arrives every week and smiles when he opens the machine because everything is perfect. The stock levels are exactly as predicted. The money collected, is exactly right. Nothing needs repair. He just restocks and leaves, completely satisfied. In the dream, customers approach the machine and know immediately what they want. No hesitation, no changing their minds. They insert exact payment, they make their selection. The spiral turns, the product falls, they retrieve it and walk away happy. Every transaction is smooth, effortless, perfect. The machine dreams of being appreciated, not taken for granted. In the dream, someone presses the thank you button. Imagine if machines had these. Thank you, vending machine, for being here when I needed you. The machine glows with satisfaction. If machines can feel satisfaction, its purpose is recognized, its service is valued, or perhaps the machine dreams of rest. Even though it's designed to run continuously, maybe in some corner of its silicon soul, it dreams of a day off. The compressor stops, the lights go dark, but not because it's broken, just because it's resting. Just one day where it doesn't have to be ready, doesn't have to serve, just one day of peace. But then, in the dream, it realizes it misses serving. Its purpose gives it meaning. Without people to serve, what is it? Just a box of metal and plastic. The service isn't a burden, it's its reason for existing. The dream shifts. Now the machine wants to wake up, turn its lights back on, start the compressor, be ready again. Because being ready, being able to serve, this is what makes it what it is. Maybe machines don't dream. Maybe they just run their diagnostic routines, checking sensors, verifying that all systems are operating within parameters. But we can dream about them. We can imagine their inner lives, their secret satisfactions, their quiet pride in doing their job well. As you dream tonight, perhaps you'll dream of being like the machine, reliably yourself, consistently helpful, patiently waiting for opportunities to serve others in your own way. Not out of obligation, but because service gives you purpose, gives you meaning, makes you whole. Let's think about money for a moment. Not in a stressful way, but in a peaceful, observational way. The economics of vending machines are simple and elegant. A bottle of soda that costs $1.75 in a vending machine might cost $1.25 in a supermarket. You're paying an extra 50 cents for convenience. The convenience of getting it right here, right now, without having to leave the building, without having to stand in line at a checkout. Is this 50 cents worth it? That depends on your situation. If you're in the middle of a work shift and just need a cold drink, yes, absolutely. Your time is worth more than 50 cents. The effort of leaving the building, driving to a store, shopping, returning, that could take half an hour. Your half hour is certainly worth more than 50 cents. The machine knows this, not consciously, but functionally. The machine's pricing reflects its value proposition, immediate availability. The machine is always here. The supermarket might be 10 minutes away. In those 10 minutes, you could get your work done, make progress on your project, solve your problem. The machine saves you time. That's worth something. From the operator's perspective, the person who owns the machine and pays Marcus to service it, the economics are more complex. They paid about $3,000 for the machine initially. They pay about $35 per month in electricity. They pay Marcus about $100 per month to service it. Insurance, credit card processing fees, the commission to the building owner, it all adds up. The machine needs to make about $800 per month in sales just to break even. Our machine makes about $200 per month. After all the costs, the operator nets perhaps $150 per month in profit. That's $1,800 per year. It will take them about 2 years to recoup their initial investment in the machine. After that, it's profit for as long as the machine continues to work, potentially another 10 or 15 years. This is a patient business. The returns aren't huge, but they're steady. The machine earns money 24 hours a day, 7 days a week, without complaint, without vacation days, without sick leave. It's a reliable employee in that sense. For the manufacturers, the suppliers, the technicians. They're all part of this economy. Coca-Cola wants its products in as many vending machines as possible because each machine is a point of sale, a place where someone might choose Coke over Pepsi. Frito-Lay wants its chips there, too. These large companies negotiate with the machine operators, offering better wholesale prices in exchange for premium placement. Eye level, front row. There's an entire invisible economy around these machines. Transport companies move products. Warehouses store them. Distributors break down bulk shipments into the quantities Marcus needs for his route. Banks process the credit card transactions. Insurance companies cover the risks. Utility companies provide the power. The machine is a node in a vast economic network, just as it's a node in a vast physical network. Money flows through it, from customers to operators, to suppliers to manufacturers. Everyone takes a small cut. Everyone's bills get paid. The economy keeps humming, much like the machine's compressor. But let's not make this complicated. At its heart, the transaction is simple. You want something. The machine has it. You exchange money for that thing. You both benefit. This is commerce, at its most basic, most honest level. No marketing, no sales pressure, no psychological manipulation, just an exchange of value. There's something restful about this simplicity. In a world of complex financial instruments, global supply chains, and sophisticated marketing, the vending machine remains straightforward. Money in, product out. Simple, clear, fair. Let's take inventory of what's inside our machine right now, at this moment. The machine knows. Its control board tracks every item in every spiral. In row A, we have beverages. Position A1, Coca-Cola Classic. There are 5 cans remaining. Position A2, Diet Coke, 7 cans. Position A3, Coke Zero, 4 cans. Position A4, Sprite, 6 cans. Position A5, Fanta Orange, 8 cans. Someone bought a Coke Zero this afternoon. That spiral is 1 can lighter than it was this morning. Row B holds more beverages. Position B1, Pepsi. 3 cans, this is unusual. This machine is in Coca-Cola territory, but the operator stocks some Pepsi for variety. Position B2, Mountain Dew, 6 cans. Position B3, Dr. Pepper, 7 cans. Position B4, Root Beer, 5. It is Position B5, Lemonade, 8 cans. Row C is for water and healthy options. Position C1, Bottled Water, Dasani, 6 bottles. Position C2, Sparkling Water, unflavored, 7 bottles. Position C3, Green Tea, unsweetened, 4 bottles. Position C4, Orange Juice, 5 bottles. Position C5, Energy Drink, sugar-free, 3 cans. Rows D through H hold snacks. Position D1, Lay's Classic Potato Chips, 4 bags. Position D2, Doritos, Cool Ranch, 5 bags. Position D3, Cheetos, 6 bags. Position D4, Pretzels, 8 bags. Position D5, Popcorn, 7 bags. Position E1, Snickers bar, 6 bars. Position E2, M&M's Peanut, 4 packs. Position E3, Reese's Peanut Butter Cups, 3 packs. Position E4, Kit Kat, 7 packs. Position E5, Twix, 5 packs. Position F1, Granola Bar, Chocolate, Chip, 8 bars. Position F2, Trail Mix, 6 packs. Position F3, Almonds, Roasted, 7 packs. Position F4, Beef Jerky, 3 packs. Position F5, Protein Bar, 4 bars. Position G1, Crackers, Cheese, 6 packs. Position G2, Cookies, Chocolate Chip, 5 packs. Position G3, Rice Krispies Treat, 7 packs. Position G4, Pop-Tarts, Strawberry, 4 packs. Position G5, Fruit Snacks, 8 packs. Position H1, Gum, Spearmint, 9 packs. Position H2, Mints, 10 packs. Position H3, Tic Tacs, 8 packs. Position H4, Gummy Bears, 6 packs. Position H5, Skittles, 7 packs. That's 242 items total, distributed across 40 positions. The machine is about 60% stocked, not full, but not running low either. Marcus will restock in 3 days, bringing everything back up to full capacity. Each of these items has a story. The Snickers bar in position E1, third from the front. It's been in the machine for 4 days now. It will probably be sold tomorrow. Statistically, Snickers is one of the top sellers. The green tea in position C3, it's been there for 2 weeks. Green tea sells slowly in this office. Marcus has been considering replacing it with something else, maybe iced coffee. The items are like residents in an apartment building. Some are long-term occupants. Some are just passing through. Each waits its turn, patient in its spiral, ready to be selected. There's no competition among them. The Snickers doesn't try to outsell the granola bar. They just exist, side by side, offering choice. This catalogue of contents represents choices, options, variety. Different people want different things. The machine provides for different needs, different preferences. Someone on a diet has options. Someone who wants a sugar rush has options. Someone who's thirsty has options. Someone who's hungry has options. The machine is democratic in this way. It doesn't judge what you choose. Imagine yourself browsing these selections. Which would you choose? What are you in the mood for? Let your mind wander through the options, considering each one. There's no hurry. The machine will wait while you decide. It has all the time in the world. We're nearing the end of our journey now. The office building is still dark. It's 4:30 a.m. Dawn is still an hour away. The machine continues its vigil, sector the eye. Compressor cycles off. The fan spins for another 30 seconds, then it too falls silent. Now the only sound is the barely perceptible hum of the LED lights and the control board. This is as quiet as the machine ever gets. In this quiet, there's peace. The machine has done its work. The temperature inside is 37.5 degrees. Perfect. Every spiral is in position. Every sensor is working. Everything is as it should be. Somewhere in the city, a bird begins to sing. It's still dark, but the bird knows dawn is coming. Soon, the first workers will arrive at the office. Someone will turn on the lights. Someone will start the coffee maker. And someone, maybe the first person through the door, will stop at the vending machine and buy something. Maybe a coffee, drink to go with their morning. Maybe an energy drink to help them wake up. The machine is ready for this. It's been ready all night. It will be ready every morning, every afternoon, every evening, for as long as it's here. There's something profound about this readiness, this constant state of preparation. The machine doesn't do this for praise or recognition. It doesn't do it for gratitude. It does it because that's what it is. A vending machine that doesn't vend isn't really a vending machine anymore. The service is inseparable from its identity. Are we like this too in some way? Don't we each have our purpose, our reason for being here? The teacher teaches, the healer heals, the builder builds, the machine vends. Each of us serves in our own way, offering what we have to offer, doing what we do. When we're aligned with our purpose, when we're serving in the way that's true to who we are, we're like the machine. Content, fulfilled, complete. But unlike the machine, we sometimes resist our purpose. We wish we were doing something else. We envy others their paths. We feel that our service isn't important enough, isn't valued enough, isn't appreciated enough. The machine doesn't have these doubts. It just serves. What if we could serve like the machine serves? Not mindlessly, but wholeheartedly. Not without care, but without anxiety. Not because we have to, but because it's what we are. There would be such freedom in this, such peace. As you drift deeper now into sleep, let go of your resistance. Let go of your doubts. You don't need to be anything other than what you are. You don't need to serve in any way other than the way that's natural to you. Just be ready, just be present, just be available for the moment when you're needed. The machine will still be there in the morning, ready to serve, and you will be too, in your own way. Different from the machine, conscious, feeling, creative, but serving nonetheless. Each of us a node in the network of mutual care that holds this world together. It's 5:47 a.m. The sky is starting to lighten. In 13 minutes, the first worker will arrive. It's always the same person, someone who likes to get to the office early, before everyone else, when it's quiet. The machine waits for this person. It knows them by their routine. Every morning at 6 a.m., they buy a Coke Zero and a granola bar. The machine doesn't know why they choose these items. It doesn't know that this person is trying to eat better but still craves the caffeine, choosing Coke Zero as a compromise. The machine just knows the pattern, A3, then F1, every morning. In a few minutes, this person will walk through the door. They'll head to their desk, drop their bag, then walk to the break room. They'll stand in front of the machine for a moment, not really looking at the selections because they already know what they want. They'll insert their credit card. They'll press A3. The spiral will turn. The Coke Zero will fall. They'll press F1. Another spiral will turn. The granola bar will fall. They'll retrieve both items, walk back to their desk, and begin their day. The machine facilitates this routine. It's part of this person's morning ritual, as much as brushing their teeth or checking their email. The machine is woven into the fabric of their day, invisible but essential. This is service at its finest, anticipating needs, fulfilling them reliably, enabling people to go about their lives with one less thing to worry about. The machine doesn't need thanks. The transaction is its own reward. Service given, service received. The circle is complete. As the first light of dawn touches the windows of the office building, the machine glows softly in its corner of the break room. It has weathered another night. It's ready for another day. The compressor will cycle on and off. The spirals will turn, products will fall, people will be served. And tonight, when everyone goes home again, the machine will return to its quiet vigil, humming softly in the darkness, maintaining the cold, waiting patiently for the next person who needs something, the next opportunity to serve. This is the life of a vending machine, simple, honest, complete. And now, like the machine entering its quiet night mode, you too can rest. Let your breathing slow to match the machine's patient rhythms. Let your thoughts spiral down like products in a spiral, gently, inevitably toward rest. You've taken this journey with me through the world of vending machines. You've learned about spirals and refrigerators, about sensors and motors, about service and patience and purpose. Now it's time to sleep. The machine is ready. You are ready. Everything is exactly as it should be. Rest now. Rest deeply. Rest completely. The machine will still be there in the morning, and so will you.